Hey, how's it going? This is how to build a link shortener with Ruby on Rails 6 part 3. So just another quick reminder, if you want to try our SaaS in a box starter kit, just click on the link right below this video and you can download that code base for free. Also, if you like this video, do me a big favor and click the thumbs up and subscribe to the channel. So in the last video, we finished setting up the model class, which allows us to actually save data to the database. So in this video, what I want to do is enhance our shortener class a little bit so that we can use it to just generate unique codes and so on and so forth. It should be pretty straightforward actually, but let's see what happens. So I'm back here in my shortener spec, and I'm going to add a spec at the bottom, and it's going to say it generates a unique or a link record with a unique short lookup code. And what I'm going to do is copy this URL here, and or this whole thing rather, and let's see, how can we do this? So I want to say expect shortener dot generate short link. Well, let's actually split this up a little bit. Let's say link equals shortener dot generate short link, and then say expect link dot expect link dot, what can I expect? URL original. This actually isn't going to be, it's probably not going to hang on to this test very long. I'm just guessing. I'm just kind of roughing something in so that we have a failing test here. But like, this really isn't a great test. So we're going to say rspec here, it's going to fail. And there's no method generate short link. So let's open up our shortener class, and let's create a new method here, generate short link, and undefined method original URL for nil class. So what we want to do here is just rough in something that's going to work, right? So what we're going to do is say link dot create, and then we're going to say original URL and then URL. And we're trying to force, in actual fact, that's no good, because that should have broken due to the link validation. So what's going on there? Let's put a create exclamation point here and see what happens. See if that does anything different. Yeah, so I guess it passed because let's try something else. So when you put an exclamation point on here, if you don't know this, it actually throws an error. I think if you don't sometimes, or not sometimes, I think if you don't have the exclamation point, it kind of fails quietly in some sense. So what we want to do here is say expect link dot to link dot valid to be true, and then we can get rid of that. That's actually a little bit better test. So let's see what happens here. Expected true and got false is what we want to see. So what we need to do here is say lookup code. So now we should be green. Okay, great. So before we go any further, I want to point out a concept which in this little application at this point in time doesn't really matter. But in the future, if you're working on something, you'll hear this concept called dependency injection. And so essentially, right here where you have this model directly referenced with the capital L, what this means is that this shortener class is dependent upon this link class. And the way that you know that is because it's literally just referenced right here. And there's this concept called dependency injection, which we won't get into very deeply, but it's good practice to follow dependency injection as much as possible, or as much as reasonable. So what I'm going to do, and this won't actually change anything in terms of the logic, and we have green tests, so we know that we can refactor, and if the tests are still green, we're fine. So what I'm going to do is say link model equals link, and then here I'm going to say at link model equals link model, and then up here we'll just say this has a link model attribute accessor, and then down here instead of directly referencing this, we can call it like that. Now the reason that you would do that is because now if we wanted to in the test, we could pass in something other than the actual link class. So if we don't want to actually talk to the real database, we could pass in a mock or something like that. I'm not actually going to be doing anything like that here because what we have is really simple, but I wanted to go ahead and point that out because this is good practice. All right, so let's go back over to our spec, and we've got in here that it generates a link with a unique lookup code. And the reason I put that is because what we want to do is say, let's get this same URL. So I'm going to call, I guess I could actually call generate, I could probably do this, right? Just call this again under, and then expect link to be valid to be true, and I'm going to make this link 2. Let's see if this is working like I'm thinking, but I think this is going to be false here. Yeah, so it's failing now, and the reason it's failing is because the URL doesn't actually have to be unique as we have defined. And so what's happening here is it tries to generate the same code with the hex digest, right? Because the URL at this point in time, as the way we've set it up, always gets the same lookup code for the same URL. So what we actually need to do, and I'm gonna just kind of hack this in to start, and then we'll maybe refactor it a bit after. But what we're gonna do here, instead of just returning this, we're gonna say loop do. So actually, let me kind of write out the steps. So the first thing we're going to do is like get a lookup code. Second thing we want to do is check if it already exists. And the third thing we want to do is break out of the loop if it does, and if not, get another code. Okay, so basically that's what our loop is meant to do. So we have code equals get lookup code here. So we want to say if I may get some syntax wrong here, so I'm gonna have to look up a couple of things. But let's say we'll say like if link model dot exists, and then we want to say lookup code is code. If that's the case, we want to break and we want to return the code. Else, that's actually wrong. We want to say, well, if that, then we want to break with code. So the default, so the way you think about if else normally, the way you should think about it, so you have if, which represents a special condition, and then you have the default. So I don't know which one you want to think of as a default. In this moment, I'm thinking about it like returning the lookup code, breaking out of this loop should be the default in my mind. Maybe not, but anyway, that's debatable. I can worry about that later. So, but if the link model exists, what's going to happen is we're going to loop through again, right? So I guess actually, let me back out of this a little bit because I think I'm confusing myself. So let's say break code unless link model exists. So what this is saying is we have a code, we look it up, and then we're going to break out if this doesn't exist in the database, which makes sense. So that means that we need to actually have some ability outside of the loop to do some counting, and you'll see what I mean in a second. So I'm going to do two things that are going to help us a little bit. I'm going to bump this out of the loop because the loop is actually part of this logic. The second thing is we only want to break out of the loop if it does not exist. So essentially what we're saying is check if this code exists in the database, and if it does, we need to get another one because that one's no good. It's already in use. So what we can do here is say we need to create some kind of iterator. And so what we're going to do is say I equals 0. And then what I'm going to do down here is say, instead of using 0, I'm going to say I, and then I'm going to do I plus 6. So this is effectively the same thing for the first loop, right? It's going to be 0 up to 6 of the characters that we're taking. What's going to happen, though, is as we go through here, I'm going to do I plus plus, or is that a thing in Ruby? We're going to try it. If it doesn't work, we will change it. It looks like it's giving me a syntax error. Equals I plus 1. Let's do that. So what's going to happen here is as we cycle through these loops, it's going to say for the first one, give me the 0 to the 6th place characters. And if that already exists in the database, it's going to go, okay, give me the 1 to the 7th place characters. Now, it's possible with this strategy that you run out of characters at some point, if you manage to get duplicates all the way up through that string. I have no idea how likely that is, and frankly, I think we may rework this this algorithm here. But that being said, let's run this and see what happens to our test over here. So we'll just do our spec, and we'll see what happens. So we're all green now. Okay, so this is cool. Let's do a little bit of refactoring here. And what I want to do is set us up. First of all, we don't need all these instructions now. Well, first of all, let's talk about refactoring just briefly because people misuse the word refactor all the time. If you're changing the behavior of something, you are changing the behavior. You're not refactoring. Refactoring means that you're changing the code, like the way that it's written, without actually modifying the behavior. So I'll show you what I mean. So we have tests, right? We know that they're all green. So if I comment out a line of code or something, I'm going to get failures. It's going to go back to red. And we know, like, I literally can't, if my tests are green because we've done this in a very particular test-driven way, it means that the behavior is still the same. So what I can do is I can actually, let's create a new method. Let's call it like get fresh code, and then let's take the iterator. And here, what I can do is just say, copy this thing, and now I can say get fresh code, iterator, and then down here I'm extending this a little bit to say iterator instead of I. So let's run this and let's see if we're green. No, I'm not. Undefined method iterator. Maybe you can't use iterator as a variable name. Okay. Let's just make that all I again and see where we are. Okay, so apparently iterator is a reserved word. Anyway, okay. So can't use the word iterator. We can use the letter I. And we can see here now that we have this get fresh code. So the reason I wanted to do this is because now, in actual fact, like we could change this to be a different algorithm. We would have to do one thing though, because what's happening is we have this test over here that it always gives the same URL for the same lookup code. In actual fact, it always gives the same URL, the same lookup code. And we've already sort of invalidated that, right? Because this now, if we run through our generate short link, doesn't work. And you can see here that it's totally invalidated because this short link actually has a different code than the first one. And that's by design. So this test really isn't really doing anything anymore. So we can actually kill this test. And you know, if you think about it, as a feature, that really doesn't even make sense. Like, we did that in the early part to kind of prove that things were really working the way that we wanted, but now we don't need this. So don't be scared to delete tests. You should be deleting tests fairly often if you're moving through code and changing things a little bit, because that's a real behavioral change. I mean, technically at this moment that test is still green, but that's not a good feature description. We don't want it to always generate the same code. And at the moment, the only reason it is because it's a special case. It's generating the same code only in the context of the very first try. So the second try is a different code than the first try, so as we loop through, right? So, you know, what we can do here is, this is actually, you might call this a private method, because it's not being accessed by anything other than this own class. So let's keep running the test to make sure we stay green over here. So I don't know if I'm going to mess with it now or not. Maybe we'll come back to it later and re-implement this somehow. But realistically, this get fresh code method is your algorithm for creating codes for people. So, you know, we don't have to use this digest SHA-256 thing. We can use a number of other methods, and we'll come back to that and try that. But anyway, so you kind of get the idea. So that's how we can refactor that a little bit. In the next video, we're going to move on to actually using this in the controller and in the view. So we'll start setting up the front end. We'll probably do a little bit more testing, probably do a little controller testing, and then you'll have a good sense for how testing works throughout Rails, which is cool. So we'll get it all built, and then maybe we'll come back and refactor this a little bit with some other strategies for this algorithm. But anyway, until next time, definitely subscribe to the channel if you want to stay in touch with this series, and like this video. It helps me out a lot, so I really appreciate you watching, and I'll talk to you next time.